And welcome back. As we continue our cosmic journey looking at galaxies, we of course have discussed our own Milky Way pretty well in depth. But let's go ahead and take a moment to kind of pan out and start looking at how we found other galaxies. The first thing you have to understand, though, before we really can look at other galaxies and what kind of makes them up, is we first have to understand that there wasn't always this consensus on the existence of galaxies. In fact, we didn't know that galaxies apart from our own existed. The very idea that there were these other bodies out there was kind of controversial. In fact, even into the 1920s, many astronomers thought the Milky Way kind of encompassed all that existed in the universe. And so when we look up the night sky, what we saw was in the Milky Way, and so that's what we thought it was. In fact, this is a very interesting thing to think about, and it wasn't because scientists didn't entertain that there's a possibility, because they were questioning the composition and structure of the universe as early as the 18th century. But it was largely due to the fact of the tools they had available. They couldn't disprove anything because the telescopes that were available, when they turned it on what we know are galaxies today, they simply just looked like small fuzzy patches of light that were really kind of difficult to distinguish from star clusters and gas and dust clouds that are part of our own galaxy. So all objects that were not sharp points of light at the time were given the same name, nebulae, which is of course the Latin word for clouds. Now, because their precise shapes were often hard to make out, and we didn't really have any techniques yet for measuring distances, the nature of the nebulae was really subject to much debate. Now, as early as the 18th century, the philosopher Immanuel Kant actually suggested that some of these nebulae that we were looking at might not simply just be clouds of gas, but actually might be distant systems of stars. But even with this, there was again a lack of evidence to support this suggestion because it was beyond the capabilities of the telescopes that we had available at that time. And so what was that big step that allowed us to look forward into the stars and really see other galaxies? Well, in the early 20th century, some nebulae had been correctly identified as star clusters, and some of these had also been identified as gaseous nebulae, such as the Orion cluster. Now, most nebulae still appeared kind of faint, and they were kind of indistinct, even with the best telescopes that we had at the time, and their distances remained relatively unknown to us. If these nebulae were nearby, the distances were comparable to those of observable stars. Well, then they have to be clouds of gas or groups of stars within our galaxies. On the other hand, if they were more remote, that meant that they were far beyond the edge of the galaxy, and they could be possibly other star systems that contain billions of their own stars. So, to really truly determine what nebulae are, astronomers had to find some way to be able to measure the distances to at least some of them. And this really kind of came about when the 2.5 meter telescope on Mount Wilson in Southern California went into operation, because it gave astronomers the chance to use that large telescope to finally settle the controversy as to what all these various fuzzy clouds they were looking at were. Now, Edwin Hubble was the one to kind of lead this charge, and he was able to resolve many individual stars in several of the brighter spiral-shaped nebulae, including M31, which was the Great Spiral in the Andromeda constellation. Now, among these stars, he discovered some faint variable stars that, when he analyzed their light curves, turned out to be Cepheids. Now, because Cepheids are some of those standard candles that we can use, it gave a very reliable indicator that Hubble could use to measure the distances to the nebulae using the technique pioneered by Henrietta Leavitt. And after much painstaking work, he estimated that the Andromeda Galaxy was about 900,000 light years away from us. Now, at that enormous distance, it could only mean that this is a separate galaxy of stars, and it was located well outside the boundaries of the Milky Way. Now, today, of course, we know that the Milky Way galaxy is slightly more than twice as distant from what Hubble's first estimate was, but his conclusion about its true nature remains unchanged, that it was another galaxy of stars. And of course, here is a rendering of what we can kind of observe with Andromeda. And whenever you hear Andromeda's catalog number M31, know that that's the same galaxy. And when we look at Andromeda, we find that is a large spiral galaxy that's very similar in appearance to, but also slightly larger than that of our own galaxy. Andromeda is about 2.5 million light years and is a spiral galaxy that is actually the closest to our own in space. There are, of course, some smaller dwarf galaxies that are near us, but when we look at the main spiral ones, this is the main one we often compare to. In fact, in this rendering here, we can see it with two satellite galaxies of its own. We see M32, which is the galaxy near the top, and then we have M110, which is a galaxy at the bottom.